This is Odie. There are two ways to connect, via Bluetooth or via cable. Let us first see how to connect via Bluetooth. First we turn on the power. And then we turn on the Bluetooth. The blue light is blinking, indicating that the Bluetooth module has power, but it is not yet connected to the computer. If we have never used Odie before, we have to pair the Bluetooth module to our computer. We go to Settings and then click on Devices. Now let Windows search for this Bluetooth module. The name of the particular Bluetooth module is Robot 2 and it is found. We click on it, enter its pin, which always is equal to 1234, and then click Connect. Odie's Bluetooth module is now paired. Our next step is to click on Devices and Printers, in order to see the COM port assigned by Windows to Odie's Bluetooth module. We see that in our case, the COM port to communicate with Odie via Bluetooth is COM9. We see now the user interface of Snap4Arduino. Observe that we have already imported the additional block commands, designed especially for Odie. In the upper right corner of the screen you can see Odie, not yet connected since the blue light is blinking. Odie's display is printing an image that corresponds to the not connected state. To connect, we click on Arduino and then on Connect Arduino. From the available COM ports, we choose the correct one, which in our case is COM9. We observe that the blue light in Odie becomes permanent. A message on the computer screen informs us that the connection procedure has begun. Odie's display also informs us of this fact. Snap4Arduino first concludes that the connection has been established and informs us of this fact with a message. Odie concludes the same thing after a few seconds, and when this happens, it produces a connection sound. Its display informs us of the fact that the connection is established, and finally a face appears on the display. We are now free to use Odie. Let us test the connection by printing something on Odie's display. We drag the appropriate block and drop it into the central part of the screen. First, we choose what to print among the available options. The simplest way of executing the block is to simply click on it. By doing that, Snap4Arduino informs us that we have to activate JavaScript extensions. We do not need to know what this is, we just need to activate it. Now we can use the block commands especially designed for Odie, and thus we can start printing. Each time we choose what to print and click on the block command, Odie's display immediately responds. We can even change the orientation of Odie's display and print things upside down. Finally, we disconnect by clicking Arduino and then disconnect Arduino. The blue light in Odie starts blinking, indicating that it is no longer connected to the computer. Snap4Arduino informs us of the disconnection through a message. Finally, Odie produces a disconnection sound and its display changes, printing the image that corresponds to the disconnected state. Let us now see how to connect through a USB cable. First, we need to turn off the Bluetooth module. Thus, no blue light is visible. Then we plug the USB cable to the communication port of ODI, and to the USB port of the computer. Our next task is to go to Devices and Printers, and see the COM port assigned to ODI by Windows. We need to search for CH340. For Windows to recognize it, the CH340 driver must be already installed. We see that in our case, the correct COM port is COM4. Back to Snap4Arduino, we click Arduino, connect Arduino, and choose the correct COM port. The rest is already described.